Pleasure to be here, and it's great to follow Rob's introductory talk because it really brought a couple of key points to mind for me. Those being that when we kicked off the attack in 2005, we were looking for exploration projects in oil and gas, much as we were with the minerals sector, hoping to actually provide key data upon which the oil and gas industry could build to explore in new areas. And we did accomplish that to some extent, particularly in frontier basins like the Chaco and the Bowser basins. But really, what became apparent pretty quickly is our methods of data gathering in oil and gas rely really heavily on very expensive proprietary stuff like seismic data and petroleum boreholes. There's not nearly as much sort of generally available public information that's as key to exploration in oil and gas as is the case for minerals. So what we ended up doing quite quickly, starting in 2008 actually in the Horn River Basin, was to look to other geoscience issues that Geoscience BC could help with on a basis that would be useful across the oil and gas industry. And what we landed upon quite quickly with our collaboration in the Horn River Basin Producers Group is the importance of water. And so what I want to talk about today are contributions to water management in the energy sector that Geoscience BC has driven since the beginning, but particularly since about 2008. So the background to that, or the key point right up front, is that our basin, the Western Canada Sedimentary Basin, including the Northwest Territories with a very key corner in northeastern BC and on into Alberta and Saskatchewan, is that it's one of the world's leading provinces for the development of unconventional oil and gas resources. That is, those resources that are hosted in rocks with substandard or poor quality reservoirs. We need a lot of water to exploit those resources, particularly through hydraulic fracturing and water floods. What we get from drilling our wells there are flowback and produced waters that require safe disposal. So water is a key issue. Surface water supplies, as we all know, are limited, more so in some areas than others. There are many competing water demands, as everyone well knows. There's a few of them there. And the key message at the bottom of all that is society in general is concerned that water use associated with unconventional hydrocarbon development can impact potable, drinkable water supplies and be a risk basically to everyone. We see those risks felt much more strongly or expressed much more strongly in some parts of our country that aren't as accustomed to the oil and gas industry. Because we've got so much information on water and on oil and gas in Western Canada, and particularly in BC, we've been able to help address some of these concerns. What we need to do is to be excellent stewards of water, both industry and regulators. And the key to the effective stewardship is to understand our water resources at regional and local levels and to manage those resources. And I'm really happy to say that in particular BC and Alberta have been very proactive in undertaking technical work and regulatory renewal to be good water stewards. And comprehensive water resource assessments are a necessary and essential foundation, and Geoscience BC truly leads the way on water assessment work. So let's talk a little bit about those assessments specifically. Water resources, quite obviously, or I guess maybe it's not that obvious, I've been around it too long, but three main settings: surface water bodies, rivers and lakes, shallow non-saline aquifers, unconsolidated sediments and shallow bedrock, and deep aquifers that host primarily saline waters. Oil and gas operators need to use these waters, so water sources to make up drilling and frac fluids, and we need water disposal zones to safely dispose of contaminated waters. We can't flow frac waters and produced waters back to the environment. That necessitates, at least under the regulatory regime and the types of basins that we have, that we use deep saline aquifers to dispose of these contaminated waters. What's generally become accepted and agreed upon over the last few years that in order to minimize our conflicts with other stakeholders, which is basically everybody else, the oil and gas industry has been encouraged to maximize the use of water from deep saline aquifers and to minimize their use of surface waters and shallow aquifers that are important to other people for their uses, particularly drinking water. So Geoscience BC has been key in funding and directing several regional resource assessments, and three I'm going to touch upon briefly today are in the Horn River Basin, the Montney Play Fairway, and the Liard Basin, all in northeastern British Columbia. These assessments are providing the technical background that operators can use to design water source and disposal programs, but it's key to realize that these are regional overview projects. They are built upon with more detailed work to provide working plans for each individual operator to figure out where they're going to get their water from and where they're going to dispose. And under the Geoscience BC principles that Rob laid out for us, the results are available to the public so that they understand the basis for the water resource planning. So here's a cartoon that's served us quite well over a number of years now, just as an example of what we do in deep saline aquifer assessments. So it's a cartoon cross-section of the Horn River Basin. The brown sort of color, yeah, it does look brown on the screen, good. Lots of shale in that basin. The gray Muskwa Shale Reservoir right at the bottom, you can see our little schematic where that's the target for shale gas development. So we drill vertical wells, turn them horizontally into Muskwa, and get lots of gas out of there. On the way down, we drill through a lot of shale, but we do see some aquifers in the Dunvegan Formation, the DeBolt, the Rundle, basal Cretaceous units, and so on, that we can use petroleum borehole data to understand the nature of those reservoirs and what their potential aquifers might be. When we undertook this project, and this was the original deep saline aquifer assessment, the original data set was strongly concentrated on basin margins because that's where the conventional gas plays were. Nobody was drilling in the middle of all that shale in the middle of the basin. So it was an interesting task to undertake that initial assessment. But by using well logs in the middle there, by looking at cores and sample cuttings, we've got a petrographic thin section showing some really nice porous dolomites from samples from drill cuttings. On the right there, we're able to construct maps of the Horn River Basin. On the left, you can see a map of porosity thickness in the DeBolt carbonate platform. Basically what that tells us is in the hot colors in the northeast, we've got some excellent aquifer capacity, thick porosity in the DeBolt that hosts a lot of saline water, and though there are great targets as water source and water disposal zones in Horn River Basin. Now, poor well control throughout the basin kind of limits things, so you can see that other parts of the basin, relatively poor DeBolt aquifer quality, although a lot of it is quite poorly known. But what it does tell us is that at least part of the Horn River Basin, the DeBolt aquifer is a suitable saline water source and disposal zone. And I'll get back to that in a few minutes. Looking at shallow aquifers, here's a map of drift thickness across the Montney Play Fairway in northeastern BC. And what we try to do is systematically characterize the unconsolidated sediments at surface and shallow bedrock. We can use outcrop mapping, we can use shallow water well data to help characterize those shallow aquifers, but we do have a very limited distribution of suitable outcrops, variable data quality, and water wells generally don't get logged in any really comprehensive fashion to understand the stratigraphy. However, they do yield water flow results that can be quite useful in understanding aquifer capacity. New work in assessing shallow aquifers is really focused, and Geoscience BC is pioneering here, on acquiring, calibrating, and interpretation of airborne EM data. In terms of assessing surface waters, the third one of our major water groups, the Northeast Water Tool has been developed between OGC, Geoscience BC, Foundry Spatial have all contributed to this, and it's a GIS-based decision support tool, so there's a lot of climate modeling, water hydrometric flow station data, just all sorts of water data that one can put together in order to assess and model water flow from basins and indeed at any specific potential takeoff point for water in the province. And the utility of that is that the operator can go in and say, what if I want to draw surface water from a particular place? I can see what the availability of the water might be. I can also see what the existing uses and existing allocations might be to see who I might be contributing with. So there's been a lot of work done in surface water assessments. So let's turn then to looking at the actual major projects, major integrated projects that have been undertaken. The Horn River Basin project, the first one, which began, say, in 2008, is actually still ongoing today. So the first major work done there was the deep saline aquifer assessment, and I showed you a couple of maps on that before, mapping in particularly the DeBolt aquifer, and it's been supported by augmented test programs. Geoscience BC actually provided funding to operators to do extra work such as deliverability tests from their shallow water wells to understand how that DeBolt aquifer might work. Now there's more work on surface water analysis. We've added through Geoscience BC stream flow and climate monitoring stations. We've also looked at acquiring and actually have done acquisition and interpretation of shallow airborne electromag surveys to delineate shallow, unconsolidated, non-saline aquifers. Had quite a bit of success doing that. Results of that work, well, Encana and Apache have built a large DeBolt water treatment project, and so much of the operation in fracking and production that they're doing in the Horn River Basin uses the DeBolt aquifer. NextSen has their own DeBolt access system to use that saline aquifer as well. The surface water data modeling that's been done supports more efficient use of the surface waters where the DeBolt aquifer is not suitable for some of the operators in different parts of the basin, and we're seeing promising results of understanding the shallow non-saline aquifers again for operators that need to access those. Moving on to the Montney water project, here's a map from OGC, I believe, that shows the Montney fairway in northeastern BC. And the Montney water project was undertaken, I think, beginning in about 2010 or 2011, following the Horn River work. It was an integrated assessment of deep saline, shallow, non-saline, and surface waters. Geoscience BC directed that project, but got a lot of industry funding and technical contributions from various agencies. It is a different play area. It's got more oil and gas infrastructure and more population in the Horn River Basin. So it was a major project, and the work is still going on, particularly in additional mapping of shallow aquifers, and I'll talk about that in a moment. The results of the work done there, what we saw was that water availability is quite variable across the Montney play fairway. It's a very large areas. There have been diverse water solutions developed, some of them such as actually constructing a water pipeline to Williston Lake for water sourcing in areas where people thought that they just really weren't going to be able to get enough from surface or subsurface sources locally. There's been agreements to use municipal wastewater to source frac operations, and Encana has built what's called the Farmington Water Hub, which combines deep saline aquifers and flowback recycling to make very efficient use of waters, and the saline aquifer work of Geoscience BC was useful in understanding how to do that. What's key in the Montney fairway right now is that many operators in today's environment are still making do with surface water sourcing, but they're going to need to develop more diverse solutions as time goes by and we ramp up for LNG export. When we get into drilling the number of wells that are needed for LNG, the water solutions are going to have to be much more creative. One key point in the Montney is that despite understanding the regional deep saline aquifers reasonably well, we've still got big challenges in adequate deep disposal, and I'll talk about that in just a moment. Finally, the third major regional assessment in the Liard Basin. This is a remote, lightly explored area. What we've done is the initial deep saline aquifer characterization, and we found that in the shallow part of the section, that yellow Matson sandstone, for example, and the Dunvegan sand right near the top, we've got some regional aquifer potential. But because it's very early days in the Liard, we're looking at this being as a very sort of proactive project. More work is going to need to be done as those resources are developed in the future. Let me just spend a minute here on current water projects. Now that Geoscience BC has directed these major regional assessments of water sourcing, or water characterization, now we're looking at specific high priority water issues. And two of these, and I think Rob mentioned both of these, is the Deep Aquifer Fluid Disposal Project and the Peace Project. So just a couple of words on each of those. The deep aquifer disposal project, so in the parts of the Montney Fairway that are being intensely developed right now, the Oil and Gas Commission pointed out that there have been issues with respect to the performance of deep injection wells. It's difficult to find zones that are suitable for injection of fairly large volumes of contaminated waters, and we need a better understanding of those reservoirs, what we're putting putting our water into, and how it's going to behave with respect to viability or continued viability of the aquifer, and it has implications for induced seismicity as well. So OGC worked with Geoscience BC on this study to investigate specific formations for the disposal capacity across the Montney Play Fairway. My firm, Petrel Robertson, was engaged on reservoir characterization. We work with Canadian Discovery, another consulting firm, to understand reservoir engineering and geomechanics. It's a big integrated report. I just chose one sample map out of it. I hope the colors look like they show fairly well. Basically, big red is gas, big green is oil, existing production. The broad fairways colored blue and green are moderately and good favorability, and I think we may have invented that word for this particular project, but it shows areas where the Belloy has good reservoir characteristics and should be a good candidate for water disposal. There are a lot of areas, particularly near existing faults, for example, where we want to be very careful about what we do with injecting our water. So we've got a good regional understanding now. This is a basis for OGC to go away and consider applications for individual water disposal wells to help understand what the risks might be to particular operators. So it's a very good regional background, again, to address a particular water issue. We reached a few conclusions that we've got our areas that are really favorable are pretty restricted by reservoir quality, faulting, and existing production. They're very, a lot of these reservoirs are very difficult to understand. They're intricate blends of lithologies, difficult to characterize from the data that we've got, and we have to be careful about not trying to dispose of water too close to existing production zones. If we do that, we risk the seal integrity of some of the disposal and the production zones, and we don't want to be crossing in between our production and our injection wells. Just moving on, the Peace Project, again, Rob mentioned this briefly, in the northwestern part of the Montney Fairway. It's a regional airborne EM survey area has been designated, and I believe that the acquisition has actually taken place. Carlos says yes. Thanks, Carlos. So what we want to do is understand what's the nature of the shallow aquifers that, in this area that carry non-saline waters. The goal of the project is to map the shallow groundwater, to provide key data to the Northeast Water Strategy, and so Geoscience B organized this collaborative effort. There's diverse government and industry participation. I think you saw Rob listed the partners up there. This map is just a preliminary sort of stitching together by Vic Levson on our project team of the existing quaternary geology maps or surficial geology maps. You can see there's a number of discontinuities in there. We really don't have a good understanding in such a large area of what the geology is. So the airborne EM has been acquired, and what we've been asked to do is to go in and look at petroleum borehole logs, and we've done which is a fairly simple but relatively novel bit of work in doing particular calibrations that the petroleum borehole gamma ray logs run through surface casing. They need to be normalized so that we can interpret the lithologies and some of the rock characteristics of the very shallow formations. We've had some pretty good success there. So there's now actually up to about 1,300 well bores that's behind this map, and this is just a very simple computer contoured map of depth to top of bedrock. And in many, many areas, we've got very shallow quaternary cover. We essentially got bedrock at surface. So as this project goes on, the calibration phase of it anyway is to integrate this petroleum borehole data with the quaternary geological mapping or surficial mapping that Vic Levson is looking at, and to produce maps from borehole control, outcrop control, the traditional areas, depth to top bedrock, nature of the aquifers, and then we're going to go calibrate that against the EM results to provide the best understanding of the shallow aquifers that might carry water in the Peace Project area. So it's a bit of a different approach, but it's the sort of thing, again, I want to come back to my point at the beginning. This is the key geological work that Geoscience BC is doing to support oil and gas exploration, not characterizing the reservoirs or things like that. That's what the oil and gas industry does directly, but this is something that's very, very useful to everyone. So let me sum up then, and if anybody afterwards wants to come up and tell me where I took this picture, I'll give you my Geoscience BC chocolate bar. Unconventional oil and gas development is placing huge new demands on water resources and aquifers everywhere. The demands can be very site-specific and in some cases can create potential for conflicts. No doubt about it, particularly when we're drilling in more populated areas like the Montney Fairway where there are existing municipalities, ranches, and things like that. And certainly we see very much the same problems in Alberta too. Innovative, integrated water resource assessments are essential tools to quantify these issues and to help design solutions. And Geoscience BC is a world leader, and I have absolutely no hesitation in saying that, in assessing water resources, and is currently undertaking new projects that are designed to address very specific water-related issues. Thanks very much.